So my name is Morakot Piluk, and we have here Ming Charles to my left, and Josh Joyner to my right.
Good afternoon.
We also have Adam Molekov, who is our product lead, sitting in front there. He was supposed to be one of the presenters, but because he got too many sessions, so he offloaded to Josh. Okay? So this session is kind of not really technical in nature, but we're going to go through things about the Internet of Things. And then we have a number of demos that put things together. So you see that we have sensors here, and over here too, and some of the secret.
Yeah, some secret stuff.
Under the table. Yeah. So 6 sessions to go through today. Start with the Internet of Things in general, and then we're going to talk about the landscape of Internet of Things and the markets in general, and then we talk about real-time GIS in relationship with Internet of Things. Then our product, GeoEvent, how it support Internet of Things connectivities and processing. And then we also talk briefly about if you want to collect data from your sensors and store it for your further analysis, how we're going to do that. Yeah, the first slide here, you could see a number of icons on screens, and that signify different kind of sensors that might be deployed in the fields, in vehicles, aircraft, or in different locations, even on people, on us, right? So the Internet of Things is pretty much network of physical objects that embedded with electronics, software sensors, and network connectivities. So this enables objects to collect and exchange data and allows them to sense and control remotely as well. Okay, just make sure I'm in sync there. So the Organization for Economic Cooperations and Development, or short for OECD, in 2015, they collect statistics on the adoptions internationally, and they came up with this chart. So Korea is on top of the list. So this chart showing that if you are having 100 people walk by you, you will find 38 devices on that 100 people. Okay? Keep in mind that one people may have multiple devices of Internet of Things. For example, I have smartwatch and I also have my phone, right? So at least I have 2. And Josh may have more. US go up, rank 3 on the list here. We found 25 devices per 100 people. China and India, surprisingly, is low on the list here, just because they have a lot more populations comparing to the number of devices being used by people. This, you should keep in mind that this is not saying anything about whether the country is high-tech or not, okay? Just number of devices being used. So look at the technology trends, how it developed. If you recall, around the year 2000, we start seeing a number of RFID tags being used on packages. If you go shopping in the electronic store, you see that strip, white strip, magnetic strip. So that's the RFID tags. Typically, when you go at the cashier, you pay money for that package, and you take out the door. Nothing should happen, but sometimes they forgot to deactivate the device. So you walk out the door, you will hear the loud beep or multiple beeps. So the RFID reader at the door of the store detect the RFID tag that has not been demagnetized and send out a beep alarm. It's kind of the starting of Internet of Things in a way. A tag doesn't need any battery, but it's activated by electromagnetic wave, enough to send the data out, right? So that has been developed over time and used in healthcare and some of the transportation securities. Some of the oil refineries start deploying RFID tag on their badge, and they install RFID readers in the buildings and the corridor everywhere. So when the people walk by, they can identify whereabout the people are in the facilities. So we are now at the year 2016, and GPS and other indoor locations start to develop and pretty mature. It can pinpoint pretty accurate location inside the buildings and outside. One of the exciting development is you can detect where people are in the building without even using or installing any sensors in the building. With your telephone, you download the applications. On your smartphones, it can read the magnetic patterns from the building's structures. And it sends that magnetic reading patterns back to the server on the cloud and do the pattern matching. And it can identify where you are inside the buildings. So pretty exciting. So these still need to be developed further. I tested it out myself, and I have found that it's pretty accurate. Right? Some other technologies like iBeacons, proximity sensors, also used in comparison with this. But iBeacon need battery power device and install it in the beacon grid in the building. When we approach the year 2020, we expect our Internet of Things devices to be smarter, and it can recognize nearby device and exchange information. So we still have to see how that will be developed in the future. So look at the devices and enabling computing technologies. We start seeing credit card size computers. Raspberry Pi that we're going to use today for the demos. Arduino, this is really small and really low cost, really affordable. Costs about $30 US dollars. We even see computer on stick like Intel's. Mostly this is used for your smart televisions. So you have Windows 10 on the stick. Costs about $100. You plug into the HDMI port, it powers, and then you can use your television just as Windows device or desktop. System on chip is another exciting development. For example, Intel Edison's come up with a very small size system, everything on the chip, that the whole computer on one chip. Stamp size, and someone put together a small cluster of that stamp size computer to expand the capabilities. So you can imagine that from the big room of cluster of computer become just a stamp size cluster. So we'll see a lot of things happening after, a couple of months or many months from now. So looking at the sensors technologies, so I talk about RFID, and the other one that you probably know about is the near field communication, or NFC. Typical application is when you put two smartphones next to each other, and then they start to exchange information. Optical text QR code is the one that you see on your badge today instead of RFID. So we can use camera to read that pattern and get information out of it. The QR code can be generated dynamically too. It's not just static one that print on your badge, but it could be on screen. Development of Bluetooth Low Energy, which mostly in your smartphone and your computer today, that allow exchange of information and interconnected connectivity between devices, computer and other peripheral as well. You have heard about Zigbee that used a lot in home automations. Exciting development is wireless power charging for power supply, like wired electricity. We don't need wire to hook into our device anymore. Just walk by, and then your device gets charged by the charger. That will enable a lot of application Internet of Things. On the landscape side, big players like Microsoft, Amazon, AT&T, IBM, Verizon, Cisco jump into the IoT landscape. They're providing IoT hub, collecting data from sensors, and provide analytics as well. So Esri is working, we are working with these companies, okay? Especially we provide special component to IoT. Expanded landscape. Now you can't even read anything on the screen, I'm sure, but just give you the idea that there are a lot more players, extended players. And I'm sure many of us in here want to be one of the players in this field. The field is now pretty much level. It's not like big company has a lot of advantage over small company. Anybody can come up in the field. So it's a good time to jump into this field. Market-wise, this is how market develop. So used to be forecasting about 26 billion units be online by 2020. I believe this was just a couple of years ago. But new forecasts say, no, not going to be just 26. It's going to be double or more. So they said 50 billion IoT objects by 2020. In terms of applications, smart cities is the one that a lot of us be involved with due to the nature of GIS, making cities smarter. Environmental monitoring is important field as well. So the rest you can see: infrastructure management, energy management, retail, medical, building, home automations, transportation, smart transit, connected car, wearable, smart agriculture. I ran into one of these interesting smart agriculture applications that they put sensor in the fields, stack of sensors, right, measuring soil moisture, chemical concentrations, the temperature and everything else. They control how long the sprinkler should be applied, when, how long, and how much. And they can even control when the crop should be harvested so that it gets to the market at the right time, maximize the profit. Some of the quote from companies that doing research and collect statistics about Internet of Things. So the market size is really big, 10 to 15 trillion. That when GE make that forecast, Cisco and other companies also up their forecasting on this as well. So these are just some quotes about how big is the market. So pretty exciting. So I'm going to go through a few applications from the list. Smart city is the first one. So people might be wondering what makes cities smart. So people have come up, or a group of people has come up with categories or indicators in different categories to say, okay, if this city is smart or not. For example, some categories are smart people, smart economy, smart environmental, smart governance, smart living. Dubai, city of Dubai, has tried to become one of the smart cities in the world. Dubai is very interesting because it's the home of about 900 or more high-rise buildings. 88 of them is taller than 180 meters or 500 feet. The tallest one is the Burj Khalifa, has 828 meters tall, or about half a mile, okay, 2,717 feet tall. Has 209 floors. It weighed more than 100,000 elephants. That's pretty interesting statistics. Yep. And interestingly, it consumes about 250,000 gallons a day with about 5,000 visitors per day. It has the fastest elevator in the world, running at 40 miles per hour from the ground to the top. It will take about 2 minutes. Okay, so it has a lot of things to manage inside of these buildings. And imagine the city with about 900 high-rise buildings, not much smaller than that, with a Palm Island and everything. You need it to make it smart to cope with how things develop inside the cities. So there's some other indicator I just want to show you quickly, that not just that one, but different group of people came up with different indicators. Hopefully in the near future, those will be consolidated and standardized. So we go into another applications, connected car, smart transit. So we have a number of automobile manufacturers that work in these fields, making car connected, connecting cars with all the infrastructures, making car connect to drivers and passengers. So there are a lot more sensors coming to the car and many new development in terms of hardware and protocol, communication protocol to exchange data. The landscape is also widened with different category of the market. Telematics, for example, location mappings, smart parking, fleet management, infotainment, and many others. I'm wondering, there's auto clean tech, that another field that we see how the fuel developed to make it smart fuel. I don't know. Wearable. So, for example, smartwatch I have is wearable. Example of wearable. You can say our smartphone is wearable too because you put it in your pocket every day, right? And on this diagram showing the survey of where do you want or people want to wear those devices. For example, 20% say, clip on my clothing. 28% say on the wrist. 18% say embedded into clothing. 3% say tattoo on my skin, right? 4% say in my contact lenses. And I saw one application that already have that on the contact lenses. Interesting. Yeah. So this one showing different sectors of the wearable. So just skim the chart quickly and see where you want to fit in. Example of wearable, how that might work. So on the left picture show the circuitry embedded into the garment directly. And at the end of the circuitry, you can attach a device. So that might measure heart rate or motions in different directions, speed of motions, direction as well. And those will connect to an on-edge hub. Most of the time we will use smartphone. It doesn't need to be a circuit connection like that. It could be Bluetooth or any different wireless connectivity. And then on the hub itself, will collect data and take care of communication to the back end or in the cloud service. So it do analysis and it will alert the parties that need to be notified. I'm gonna give a short demo, a quick demo, using the smartphone as sensors. So these are sensors that you might find on the smartphones. There are 15 to more than 20 sensors. If you are not realizing what are you measuring, you are walking sensors, okay? Sending information out every day to the back end somewhere. Some of those might concern your privacy, but we have so much control over that, right? So accelerometer, for example, will measure motion, check tilt. You measure ambient temperature, gravity, direction, gyroscope, lighting, magnetic field, I mentioned that. Orientation, pressure, proximity, how far are you from other phone or even phone from your face, or other devices. Humidity, temperature, many more that we are measuring that. So the demos work like this. I have a small piece of software installed on this device that I developed, reading data from the accelerometers, and we send to our backend GeoEvent in the cloud, on the Amazon EC2 machines. And then it will do the detection. If I move too fast or anything, it will send back the alerting to my computer here, which is a different device, and then output will go out to the speaker to a text-to-speech. So let's test it out. I move it slowly, and nothing happened. And I jump. Oh, let's see if I did find it. Let me check first. Okay, I need to.
Make sure it's not on mute. You get your volume up?
Oh yeah, that's right. That's how.
Number 17,777. Standing by for messages.
Okay, try again. Move slowly. I walk normally, right? And then I fall or jump.
I got to push you off the stage, I think.
Hi, Morocco. Glad you are okay. Take care.
So I happen to touch the button to say I'm okay.
Hi, Morocco. Fall incident detected. Are you okay?
So if I'm okay, right? I should be able to, oh yeah, I'm okay. I touch the button,
Hi, Morocco.
notify the server back.
You are okay. Take care.
See? Yeah. So I try again. I go,
Don't forget your mic.
and then I jump.
Hi, Morocco. Fall incident detected. Are you okay?
I'm okay. I'm green.
Hi, Morocco. Glad you are okay. Take care.
Yep. So this typical application is used for elderly monitoring. There's a real application for that. So you have a device and detect if some abrupt movement or motion happen. It send that check with the caretaker who's sitting somewhere else, and then with the automation like this, it can help. If you're okay, press something. Let us know. Wow, glad it worked. It's always risky to do live demo.
Yeah, it's a little scary.
So I'm going to hand this over to Josh to do the next section about the connected environment.
Excellent. Well, I'm going to kind of work with both computers at the same time. One of the areas that's seen the most growth in IoT technology in recent years has been with connected environments. Meng's going to have a demo on this in just a few minutes. But really what we're talking about is sensors that are monitoring soil, water, or air quality. The benefits of which we're already seeing with smart agriculture. And Morkat gave an example of this earlier, but it's allowing farms to better manage their resources and to be alerted to problems, indicators of problems before they arise. So if maybe they have soil that's drying out, they need to be aware of that before it gets to the point that they start losing money. And the benefit of this is this kind of technology, the cost of these things have come down significantly in recent years. And it's really designed so you can deploy these throughout an environment. And similar to some of the examples that Morkat showed earlier with some of the small computers, the Raspberry Pi, the sensors themselves have come down in price significantly. There's a number of DIY kits, like you see some of these here, for monitoring moisture and wind speed. And each of these can be packaged with kind of do-it-yourself kits or kind of prepackaged units that are designed so you can put them throughout an environment. Let's see if I can jump between. Yeah, maybe? Yeah. So you may be surprised to know that I would probably guess most people in this room actually have some of this technology already in your homes and offices, whether it's a wireless security system or irrigation, or maybe just one of the newer smart utility monitors. Many of the functions of our homes are increasingly becoming automated. And for families or companies that are looking to kind of reduce that energy footprint or maybe just to reduce some of their energy cost, there's a number of devices and sensors that can be placed throughout the home that can monitor the water usage, the energy usage, so you can kind of see throughout the day. Maybe my TV is running when it shouldn't be. You're getting charged for that, so that's extra power, extra money you're having to spend on these things. So these are sensors that can be monitored in real time and allow you to make better informed decisions on your environment. I'll switch over. So for people wanting to get into integrating some of this IoT technology into their homes, one of the easiest to see, if you can kind of forgive the pun, would be through lighting. We're going to be using today, and this is where the toys start to come out. I feel like what's that, Carrot Top, where he keeps bringing out toys and stuff. So what we're going to be working with today is going to be a Philips Hue device. This is actually a wireless light, so it's completely wireless, no wire. It does have a battery-powered charging. And the benefit of this kind of system, and this is just a small part of the Philips system, it's not just a way to turn the lights on and on. We had that 30 years ago, so we kind of tell people's ages. We had the clapper, clap on, clap off. I won't sing it, so it's not stuck in your head the rest of the day. But This allows complete control over your lighting in the house. You can control it to sync up with music, with movies. It can control, you can do proximity sensors. So, I walk in the front door of my house, the lights can flash and warn my kids to, stop playing their video games and switch to homework because they know Dad is home. You can set lots of different controls with this. Let's switch over here. One of the other areas we've seen a lot of growth with has been with the market side for IoT. The device you see here in the top left corner, that's an Amazon Echo, sometimes described as Siri on steroids. So this is a home automation device that Amazon has provided. You can walk into any room and you say, Alexa, that's the name of their unit. Alexa, what's the temperature outside? Alexa, what's 5 times 5? Just, any kind of question you would ask your smartphone now. But one of the biggest pushes for this is that it's linked to Amazon Prime. And so it knows your shopping history through Amazon. So you could say, Alexa, order shaving cream. And it'll look back through your previous shopping history with Amazon, automatically order that for you, and get it sent out to you. For people that are using the same products every week, so like in my house, we've used the same detergent for the last 10 years. Every day I make lunches for my kids. I'm using the same size Ziploc bag. What Amazon has also released is this thing called, right here, this is their dash button. Amazon makes buttons for, right now they have over 100 different brands. And the way this works, and this is I think, genius on their part, you put this, so this one here is for Nature Valley granola bars. So we go through this every day in our house. Put this in the pantry, grab the last bar, press the button, light changes color, blinks for a few seconds, and it orders it for me. 2 days later, I get a package from Amazon with more granola bars. You get these throughout the house. There's a little sticker on the back. You stick it on the dishwasher. You stick it on the washing machine. Whatever you need, whatever products you're continually using, these are tied to a specific brand, which you select, press the button, and it orders it for you. It basically simplifies the process as much as you can for shopping. And it's a great device to get started with. The neat thing about it, too, is effectively there's no cost for users. So right now, Amazon has these for $4.99. Not that I'm working for Amazon or anything, but they're $4.99. But then the first time you buy something, you get that money back. So it's a cool way for people that just want to play with it. Hey, may as well pick a brand you like and order a couple and get them. I know a couple of us in the room on the team have bought some just for the sake of having them. So it's pretty neat.
So the package will come over the drone delivery.
Yeah, it works pretty good. So our main interest, of course, the fact that we're here at the conference, we want to talk about how this is related with real-time GIS. Let me switch to make sure I'm synced up here. So one of the main benefits with IoT and GIS is one that allows us to put these sensors in more locations. We can get a much more accurate picture of the environments we're studying, and we're able to more accurately and more rapidly determine these patterns, be alerted to problems as they arise. So we're no longer reliant upon an individual in the field reporting information. We have automated sensors that are returning this information spread throughout an environment. We can feed this into our products, and then we can return the results on those. So this kind of data that we're working with here, we consider this observational data. So it's a little bit different, maybe some more traditional data types. Let me pull this through. Is it linking through? So this data that we're working with here, we're a little bit different from some other types is that we're not editing this information. As it's coming through at a set point in time. It's coming to at a set location. So information that's captured here in this room at this moment is going to be different from what's captured 5 minutes from now, or what's captured on the other side of the convention center. And by having more of these sensors and having more of this data coming through, it allows us to go through and see how these things have affected the other components. If we're working with moving objects, something like a vehicle, we're able to define a unique track ID, and we can identify tracks. We can look over time where an individual vehicle or an object may move throughout an environment. So what we were working with before was maybe some sensor data that wasn't moving. It was just bringing new information in. We can also work with data that's moving, and we can let it make tracks. Sometimes this has been referred to as kind of a film strip view. So each frame in that film strip is a snapshot in time. We're able to watch that go forward, watch it and rewind, fast forward, and we can see how events have changed throughout an environment. So obviously we wouldn't be talking about all of this here if Esri didn't have a part to play in IoT in real time. All of us here are on the real-time team. And Esri's primary platform for working with real-time data is the GeoEvent Extension for ArcGIS Server. And it's our primary program for bringing in IoT data. It can also be used for bringing in any of the vehicle location data, any of the sensor data. We're able to ingest that in as well as perform real-time analytics on the data. We're able to visualize that through some of our stream and feature services. We're also able to store that data. It allows it to be queried back rapidly later. The other wonderful benefit of this component is we're able to use it with non-traditional GIS sources as well. So if we were monitoring certain weather conditions, when something has changed, a sensor picks up a new condition, we want to be alerted to it. We just don't want to write it to a database. We want to be able to send out alerts via either email or text messaging, maybe a non-traditional GIS source certainly, to alert people of a changing condition. So now that we kind of see how we can bring GeoEvent into it and bring the Esri platforms into it, I want to give it back to Morcott for just a second to kind of talk us through the demo he just showed, but behind the scenes, what it's actually doing and how we got that to work for him.
Right, so just to recap this, I have GeoEvent show up on the diagram before, but I didn't say anything much about it. But now Josh has demystified it. So let's bring that back and see how the backend server was configured to work, right? So you see my phone sent data remotely to the input that called RT device JSON. So it's using JSON format, sending from this phone, from my app. And then we have a diagram that I call it logic diagram, that I put filters and things. It's kind of like circuit in your electronic as well. So data flow from the left, passing through filter, say if the reading from accelerometer is more than some certain values, I signify that as a fall.
Fall incident detected. Are you okay?
Exactly. So, and then I pass through a processor that will configure the message that's sent back to the speaker, right? And that if it detected fall, it say, "Hi, Morcott, detected fall. Are you okay?" And if I'm okay, then I press this button. It will go to the lower part of the diagram. It's receiving that I'm okay, and then it just format the output string, text string, send back to the text-to-speech engine, which is running on the computer here, and then set it out. So that's pretty much. All right, back to, we go to Ming this time. So he will show his demo. Okay, I'm going to hand over my microphone as well.
I think I can probably do it. I'll move over here. All right. All right. Thank you, Morcott. Well, hopefully someone will take that concept and create a business that will compete with Life Alert. So before I get into the demo, I'm going to show you this diagram of an IoT architecture. There are many different shapes and forms of IoT solutions, and the architectures may be different. But this diagram shows the basic elements that are involved in most IoT solutions. It also matches the demo that we're going to show. So at the very bottom, we have sensors, actuators, and displays. They are the edge devices, and they're responsible for communicating with the outside world. Then we have the application framework and the service gateways. Their functions are to manage the devices and software that's running at the edge, and then also communicate with the cloud. Both of these layers typically run on the IoT devices. And then the IoT integration platform on cloud, it functions as a central collection and the dissemination point of IoT data. And you can view it as a real-time event hub or IoT hub. Amazon, Azure, both have their IoT hubs that are running on their cloud. In this demo, we are using the IoT hub hosted by Eclipse. And you can use any IoT hub as long as your service gateway and business applications support it. The business application layer is where the GeoEvent extension fits in. It ingests data from the IoT integration platform, and it performs real-time analytics. It can generate notifications or alerts. It can also write commands back to the IoT integration platform to instruct the devices to perform certain tasks, such as turning on a light or changing the color of a light bulb.
I was doing down.
Oh, this one. Okay, so our demo follows that architecture. And we're going to use Raspberry Pis and the Philips Hue as the IoT devices. We're going to use the Eclipse IoT sandbox as the IoT integration platform. And we're also going to use the GeoEvent extension as the business application. We have a custom transport that's built on the library called PAHO that communicates with the MQTT broker. And so here I have a Raspberry Pi that has a temperature sensor attached to it. And over there's another Raspberry Pi that has an LED light attached to it. And both devices, they have a wireless adapter on them, so they communicate with the internet. And both devices have a software module called Cura installed on it. Cura is an application container based on OSGI. It has modules that enable the device to read sensors and to control the actuators while communicating with the MQTT broker. And the MQTT broker can be anywhere on the internet. And also, we have a Philips Hue personal wireless lighting system set up here. And the system contains a bridge, Hue bridge, which communicates with the outside world through a portal. And also manages all the light bulbs that are connected to it. Oh, where's the this is the bridge.
Yep, sorry, it's right here.
Yeah, sorry. All right, so Josh is going to get into more details of the Hue architecture in the next segment of the presentation. So here's the sequence of events. This Raspberry Pi updates the IoT integration platform whenever it detects temperature change from its sensor. And the GeoEvent extension has an input that subscribes to the the IoT integration platform, and it gets notified when the temperature is changed. And then it calculates the color of the Hue light bulb and sends the HTTP request to the Hue bridge here. And the Hue bridge updates the color on the Hue light bulb. In addition to changing the color of the Hue light bulb, it also turns the LED light on and off on the other Raspberry Pi when the temperature reaches a certain point. So the two Raspberry Pis are not connected to the GeoEvent directly. They are connected individually to the IoT integration platform. This enhances the flexibility and the adaptability of the IoT devices. The IoT integration platform does not have any business logics related to the devices that are connected to it. It merely hosts data for them. There could be many services behind it that offer different business solutions. So GeoEvent is a perfect example. So in this demo, it has a service that reads the temperature data from the topic. It subscribes on the MQTT broker and then sends updates to a REST endpoint on the Hue bridge. It also publishes data back to another topic on the MQTT broker, which turns the LED light on and off. And the Hue bridge and the GeoEvent, on the other hand, it must be running on the same network. because GeoEvent sends data directly to the REST endpoint on the Hue bridge. So in this case, the GeoEvent also acts as a portal for the Hue bridge. So we have introduced a few names outside the realm of ArcGIS and GeoEvent, and they may be new to you. So let's go over them again, and then we can have a good understanding of what we are doing here. So the MQTT is a protocol that is popular in the Internet of Things world because it's lightweight and low bandwidth requirement. It employs a publish-subscribe model. And QRAR is an application framework that allows the IoT devices to communicate with underlying hardware such as sensors and actuators, and then also with the IoT integration platform. And PAHO is a library that facilitates the communication with the MQTT protocol. It comes with different flavors. We used its Java-based library in our custom transport to publish and subscribe data from the MQTT broker. So let's start the demo. Do we need to turn the Hue light bulb on?
Okay, let's pull it in time. Give it 1 second.
Okay.
Let's catch up.
All right, so I'm going to put my fingers on this temperature sensor and to make the temperature go up. So as you can see that when the temperature goes up, the color of the Hue light bulb changes from a bluish color. It's going to eventually change to red color. But every time when I do the demo, my finger gets very cold. Do you want to try?
Somebody else want to try?
Oh, yeah, it's just taking a while.
You heat it up too.
Go. Your fingers are too cold.
It's going to.
Probably have to send me to run around 2 rounds.
Give it the exercise here. Let's see if I can warmer. Oh, I'm colder. That's not working. Wait, I'm going the wrong direction here. Come on. Gotta heat my fingers up. Need some coffee or something.
Yeah, we should have got some hot water.
You can put it behind my machine here. It's got
Oh, yeah, that's a good idea. So the idea is that it's going to eventually change to a red color. It's getting redder, getting warmer. And then it will. Yeah,
You gonna get warm enough?
not warm
You
enough.
need some coffee.
And then when it reaches a certain point, the LED light should show up. But you get the idea. I don't think I can get to that temperature right now. But I'm going to play this video, actually, because people watching it from the...
There you go. There we go.
You're good. You're good. Well, bravo. Bravo. Yeah.
The joy of Windows computers that run hot.
Okay, so once you move the finger away from that, it's going to come down. And I think
hot back there.
yeah, it's getting pretty hot.
Let's go.
Leave it there. You'll watch
Okay.
it get cool. Yeah.
So I'm going to actually play this video so people watching this slide presentation at home can see. Click on it. Oh, it's already started. Okay, so here I have this Raspberry Pi with a temperature sensor, and here I have the Raspberry Pi with the LED light. And Josh is holding this light bulb in his hand that is showing a bluish color. So I was going to put the fingers on the temperature sensor, just like what I just did, and it changes the light bulb color from a bluish color to a red color. And also at a certain point, the LED light also will turn on when it gets to red.
It's worth noting that Josh was in Charlotte.
Yes.
He was in Redlands, California.
Right.
Yeah, this is completely across the country, back and forth,
Right.
and in real time, it's turning the light and changing the color as he's pressing
Right.
it.
Yeah, so we recorded this video last week, and Josh was, like Adam said, in North Carolina, Charlotte office, and I was sitting in the Redlands office. So those Raspberry Pis were sitting on my desk in Redlands office. So, okay.
The light turned blue now.
Yeah, I think there's something wrong with the internet access. Probably the signal didn't send out as quickly.
No, it's
probably.
the temperature is
Oh, the temperature.
Yeah.
Okay. So yeah, here in the video, I was doing it again to make the temperature go up, and the light bulb changes color to red. All right. So I'm going to the next slide. So this is the GeoEvent service that enables the hue color change. It uses an MQTT input to receive temperature data, and then it uses a field calculator to convert the temperature from Celsius to Fahrenheit. It then uses a filter to cap the top temperature because we want the top temperature to stay in red, in the color of red. So with our temperature to hue calculation, if the temperature is above the limit, we set the color will continue to change. The color will continue to change, but we don't want it to go past red. We just want it to stay in red. So that's why we have this filter here, and then. We also have a field calculator that actually converts the temperature reading to the hue value. That's how it changes have different values for the color. And in the end, we're using a out-of-the-box HTTP output to send a REST REST request to the REST endpoint of this hue bridge, so that it will actually change the color of the light bulb. And here is the second service, which controls the LED light on the Raspberry Pi. So similar to the previous service, we used an input to receive temperature updates. We then used the two filters to set a temperature threshold. When the temperature is above certain value, we use the field calculator to put the word on in the output event. When the temperature is below that, we use another field calculator to put the word off in the output event. The output event goes to the MQTT output, which publishes the event to a particular topic on the IoT integration platform. So the demo is quite simple, but it illustrates the architecture of an IoT solution. It demonstrates how GeoEvent can be used as an IoT application. In reality, the devices could be cars, appliances, or sensors connected to an IoT hub, and they may have location information attached. The IoT hub could be Amazon, Azure, Cisco, or any other cloud service that provides the integration platform. The real-time analysis could be more complicated, and the output may involve mapping or notifications. These characteristics of IoT solutions all align with the functions provided by the ArcGIS server and GeoEvent extension. So if you are interested, you can get some hands-on experience by setting this demo up by yourself. Here are the resources that can help you to build this demo. The first link points to a website that talks about how to set up the Raspberry Pis. And the second link talks about the IoT integration platform, which is the MQTT broker that's hosted by eclipse.org. And the third link is actually our custom transport that we built, we put on the GitHub. And it uses the PAHO library to publish data to the IoT hub or subscribe data from the IoT hub. And finally, the last link talks about how to send commands to the Hue light bulb. So with that, I'm going to turn it over to Josh.
Great, thanks, Ming. So live demos are always a little bit scary because we never know that stuff's going to work, and we like that you get to put us on the spot here. But we've been pretty lucky so far. So now we're going to make it complicated. So we're going to try and make it a little, just kind of shoot for the moon, see if we can do it. I need to get 2 volunteers for this, though, because this is going to be a little more challenging. There's 1. I need 1 more. 2 in the back corner. Come on. So I'm going to take off mic for a minute just so I can talk loud. You guys can hear me. So come on up. Everybody can see. So we've already seen with Ming's demo, and I'll put this back on so they can hear us for this recording. So we've already seen with Ming's demo that we can change the color to any color that we want. For what we're doing here, I only care about 2 colors, though. I want to care about green and red. So this is just like the children's game you guys probably all played, or those that have kids have played. Red light, green light. So just a reminder how this game works.
One is out.
Somebody was moving.
Reminder. Red means stop.
Okay, red means stop.
Just a reminder. Red means stop.
All right, so we're going to go back to green. Oh, you're both moving. Come on, guys, we haven't even started yet. All right. Okay, so now we're on green. So why don't you guys, we'll reset it. We'll play safe. And stop.
Runner number 2 is out.
I don't know. That was pretty close.
Reminder. Red means stop.
All right.
Runner number 2 is out.
All right, let's get you back
luck
again.
Next time.
All right, back to green. All right, try again.
Runner number 2 is out.
Runner number 2, man, he's just struggling today. I don't know what he's doing. Well, I appreciate it, guys. Well, we got some stuff to help you guys.
Runner number 2 is out.
Man, he's just
Better
struggling.
luck next
All right, so
time.
we got for number 1.
Is out.
There you go. We got a trophy.
Just a reminder. Red means stop.
Oh, you got to fix that.
Runner
Absolutely.
number 2 is out.
Stop talking.
Better luck next time.
All right, let me switch this back.
Runner
over here.
number 2 is out.
Stop talking. Here we go. Cool. So let's switch over to what we did here. And just for the people at home, I made some guys in the office do it. We're just going to play this real quick so the recording has it on here as well. I can click. All right, so just like the kids. Oh, you don't have the audio on there. That's all right. That's green. Walk. All right. Walk. Yeah. Both on mic. Ready? Get stop. Ready? Okay. Walk forward just a little bit, Scott.
Runner 1 is out.
Gotcha.
Just a reminder. Red means stop.
So it's not just number 2. So I don't want him thinking it was we were cheating on him and that, number 1 can break also. Yeah. So what did we do here in this case? So we did say this was a little bit more complicated. So the way this works is I'm actually wearing an Apple Watch. And I am running a very simple application on here, which is by Philips Hue as well. It allows me to change the color between green and red as I change the colors. A little bit of delay here. Catch up. There we go. So it switches back and forth between them. That's connected with Bluetooth to another application I'm running, which is another application here on my phone that allows me to do changing the colors on the device when it's communicating. Maybe a little bit of a delay. So another Philips application here. All of this is actually running over Wi-Fi, and in fact, this is all running off of a hotspot off of my phone. So it's a wearable device working as its own wireless network that all of our stuff is running off of. The laptops and everything are running off of a wireless hotspot off of my phone. So that's showing right there what IoT technology can do. That's communicating with the Philips Bridge. That's this device right here. This is a small portal that has to be on a wired network, which it is. It is wired to my laptop. And this will communicate. It'll send the signals over to the Philips Hue. Now we have an example here with one of their wireless lights. They also have just regular light bulbs and different units that you can also connect to. It'll send information such as the brightness, the color, whether it turns on or off, whether it's going to flash. It'll also send that information out to a REST input, which is what Ming was using for his demo. And it also sends it out to Philips Cloud Server so that people don't want to manage the lights from home. They can connect to Philips websites and change the colors for that. And you can see, just like we did before with our demo, we change it from red, we change it to green. And what we saw with the earlier demos is that we're able to send a message from GeoEvent running on our laptops, send it out to that REST endpoint that the bridge provides, and we're able to change those colors. Again, just like we did red to green. What we did in that last demo to make things a little more interesting is we're able to actually send a GET request to that bridge. So we're able to get the current state of the light at that any time. So that's how, when I was able to change the color of the light, we were able to query that bridge and find out what those values were. And then we were able to compare that to the motion of our badges. And I apologize, my graphic had a boy and a girl, so we had two guys, but it's okay. So behind each one of those badges were two old iPhones that I took away from my kids. They didn't want to play with them anymore, so I grabbed them. And you can see running on the back of each one of these is just Velcroed onto some old repurposed badges from previous conferences. And we were running an application on there called Sensor Data by Wavefront Labs. It's an iOS application for it. There's a number of different ones for both Android and iOS that allow you to capture that sensor data, similar to what Moorcott was showing earlier. Maybe, change. Lost the, I'm on the wrong screen, maybe? There we go. Sorry, I was on the wrong screen. So when you look at this as the full big picture, this is what we were working with for IoT devices today. So we have the wearable watch connecting to the phone, connecting to the bridge, connecting to the light, connecting with REST, connecting to the sensors, connecting to the application that we had that spoke when we were walking. So we had everything running together for us. Now behind the scenes, what we were doing from the GeoEvent side, let me turn this around so I can see it. I can make sure I'm telling you the right steps when I'm telling you here. So this first sensor, this first service was polling the conditions of the light. So the green box there is running the query of the light state. So we're sending a query out to that bridge. We want to know what colors we're working with. And what we're doing is, the next step there is a field mapper. So we're taking the information provided from the light, from that bridge, and we're converting it to a definition that matches what we need. We're then adding some geometry. What we're going to be working with is we're using a geotag and the geofence capability of the GeoEvent Extension that allows us to compare the geometry of that location. So each of these phones were transmitting the coordinate information, which we were able to compare on the fly with a bounding box that we created for this area. So the last two yellow boxes there, that's the really important part of this step, is we're changing the colors. So we're converting the value of what we have coming through as a value of 108, as you see there. We're able to convert that into true. So whenever GeoEvent queries that service and it gets back a value of 108, we're setting that as a value of true. We also have the next one for green. Whenever it gets the color value for green, converts that to false. So when we bring this into the service, we're able to then compare that to the motion information provided by the phones. So if you notice here, we have two tracks that are very similar, the top track and the bottom track. The reason we did that is we're running two different devices, so we had to duplicate what we were doing. And the only reason we had to do that is these two devices don't have any way of identifying themselves. Most devices that you'd be working with, if you're working with connected vehicles or connected home sensors, you would have some kind of identifying feature, but the applications we were using did not, unfortunately, so that's why we had to kind of duplicate that. So what we had to do is we had to add some information. First, filtering. We want to filter over a certain speed, so we want to capture if there's that acceleration value we discussed. We want to know which runner we're using. And the most important one is that box that joins the two of them. That's where we added that state from that geofence. So we wanted to know if it was true or false. So basically, we have the runner. If it's over a certain speed, we add the information about the geofence. We determine whether or not that fence is active at that time. And if it is, we send that out. One is an alert to this, to flash red. And we have a second one that went to the text-to-speech app that Moorcott was showing. So we're going to kick things back to Moorcott here, who's going to wrap up for us.
Right, so the last thing we want to talk about is, okay, we get all those data coming from different devices. if you want to collect them to analyze why runner number 2 is always, couldn't stop in time, what happened? So we need to record that data, and we can analyze his motion patterns and identify, because you lift your right legs too high, something like that. And GeoEvent provide the output connectors to record the data either into the relational database through feature services, through output like text file in CSV, JSON, XML format, send email or do whatever, other things, send tweet even. We also, in 10.4, come out with a big data store that allows you to record if your data coming in high frequency, high volume, that's surpassing a few thousand messages per second. So the big data store allows you to write at the rate of more than 10,000 records per second, as opposed to typical relational backend that do only 300 or 400 messages per second. That won't be enough for your high volume. Important things on this diagram, you can see that you can scale out the big data store by adding more nodes if your output going to be higher than that rate, right? You can add node 1, node 2, form a cluster. You also get high availability, auto replications, fail-safe for free. In summary, so we know that the Internet of Things is a fast-growing field, and still a lot more to come for us to discover. More devices, more sensors. The price are going down quickly for platforms and sensors. New protocol going to be coming out, and data format, also new standards. So watch out for that. New applications. This is something that we might be involved in developing or help providing solutions. New challenges. So scalability, as more devices become available, we need to deal with them, right? If they need to send data to our server, you need to deal with high volume, high availability, analytics, storage volume. Also, security is a big thing that a lot of people are concerned, because you don't want someone faking as your device and sending data to your server and pretend to be a device, or even a vehicle, even as a plane. So you need to make sure that transmission is secure. Visualizations of big data has become a big challenge. You might want to do aggregation display instead of display all the 50 million devices on your web map. That doesn't work, right? You need different technique to visualize that. So the real-time GIS will help taking care of some of this, not all of them. So we want to increase the ingestion rate. We're working on that pretty hard. We want to be able to handle bursty data, meaning that if millions of people or devices sending data at the same time to the server, will your server survive? So we have to have a way to deal with that. And also, if a lot of device sending, can you analyze, or your analytic portion deal with it? So we're working on that too. High volume storage, historical, how long you want to keep your data around? 1 year, 2 years, 7 years? Something like that. We need to be able to deal with it. For example, your active database might be keeping for 6 months. Then you have secondary storage that keep it for longer term, something like that. So we need to add data management into that. So that wrap up our demo presentation today on the IoT, and we have a lot more sessions if you want to learn more about GeoEvent Real-Time GIS. So this is a survey form. Yep. Now we don't have a form, we have an app, right? You help us evaluate. Oh, sorry. Oh, why is it going so quickly in there?
Back to the sessions. We have 4 more sessions left this week. There's 1 more session in the demo theater 5 downstairs. Morcott's going to be showing that later this afternoon, and we have 3 tomorrow, 4 tomorrow as well that are listed on here.
All right.
Also for tomorrow, I want to let everybody know we are going to be setting up all of these sensors at the Real-Time GIS booth, so you guys can come and play with them tomorrow and get a little hands-on look at how everything is set up here.
All right, we're open for questions. If you have, any of you have questions, let us know. Yep, any questions? Okay, go ahead.
How can reading and hearing about live file, not Wi-Fi, but live file, with the
I have not.
It's not one I've worked with, no.
I have to learn from you. Thank you.
Yeah.
Yeah, talk to us about that. Yeah, we're going to collect to our list. Any other questions? Okay, over there. Please.
Can you explain again how MQTT works?
Me?
Well, MQTT
Wait. Need the mic.
So MQTT, the question is how MQTT works. MQTT is a protocol similar to like TCP or REST, and it uses a publish and subscribe model. So you can just subscribe to a topic that is hosted by an MQTT broker, and you can also publish to a different topic that's hosted by the broker. So it's the advantage of that is it's lightweight. So it's very popular in the IoT world.
Any others?
All right, thank you then.
Thank you.